let me jump right into this. Seems like we've been all misled a little bit with the drawings and plans. This is the NTSB, as you guys might be able to find this video, and the NTSB guy showing the plans. Take note of the date of the plans, 12/9/16. This is what they presented to the public with the plans stamped on it. Now they're the NTSB supposed to be investigating this scene, and it appears that they're putting out misinformation, knowing they had to know that these aren't the current plans, the 12/9/16 plans. And if they didn't know wrong plans, this would be impossible to investigate properly because you wouldn't know, all the details would be wrong you're looking at with the old plans. So you would be thinking everything's okay, you wouldn't know what was wrong, and all the evidence is gone by the time you get the right plans. I want to know if they got the right plans, and if they have them now, and when did they get them? So now we see the plans are April 2017. So the NTSB put out plans showing 16. They put out old plans, or led us to believe to go look for these old plans. Either they were given false plans. So how can we expect the NTSB to do a proper examination and are qualified to make any statement if they can't even figure out how to get the current plans? You know, it's amazing that they had to send the airplane expert down there to investigate a bridge failure. That's brilliant. I'd be real great at a air crash scene myself. Put me in charge. I'm being facetious. Terrible. This is terrible, you know, and these aren't even the full current plans because we still got rebar and not post-tensioning. So the FDOT is not putting out the correct plans either. They need to update what they're releasing to us with the amendments or addendums. Let's just jump right into the canopy. The canopy appears to have 4 post-tension members, and there's so many awesome things here. I'm really excited about being able to have these details now. These are the stamp drawings. They're the latest stamp drawings of 4/7/17. Not the latest stamp drawings that I have in my possession at this point. It shows total of, and this is the canopy. I got to confirm this is the canopy with you guys. There's 8 members up here. The first drawings we saw, the rendition had 6, 3 and 3. It appears at this time the update has a total of 8. And remember, in the middle are the nodes, the bar blisters. This makes this canopy structurally much more sound. And what's even more awesome, which I'll show further in these details, and I'm going to do a few videos on this because I actually have to get to work, but I wanted to put this out this morning for you, is that they did they addressed some issues of the load being at the bar blisters. Look out with my converts that aren't quite converts. Maybe this will make you more of a convert. These are the original drawings. As we saw in just the previous image, they now have this as 8 members and not 8 post-tension members and not 6. As you always recall, as you might recall, that I've always had this as a weak point with this blister here forcing out. My thinking is that the first draft, the engineer stamped, it went forward to the next engineer that was supposed to inspect it for quality, and he looked at it, or she looked at it, or a team looked at it, and they said, we don't like this area up here, let's go ahead and increase the post-tensioning post-tensioning members here and here, increasing it by a significant factor, adding 2 more members. Okay, we're moving on there. So you guys can see that this has always been something I thought was wrong, and now I don't want to pat myself on the back, but this would have been Pate's original plans, and he stamped it already at this point. These are stamped plans. So I don't think that he went back in his mind and said, you know what, I should add more there. I don't think that doubt came. I think it came from the second inspecting engineer, if you will, firm. And they said, this node, we need to address this load path up here more. So you guys follow me on that. That's always been my problem up here, and it still is. But let's move on. So here's the directions of the post-tension cables, and here's a grout tube. This is the grout tube, what it looks like. It gets inside here and grouts down this tube. As you know, they're ungrouted. Ironically, I've only been able to breeze through this, and I have not been able to find the detail where it says grout the members. So this is Denny Pate. Now, we're going to have to backtrack, a lot of us, on a lot of things. At least my position is that this had a lot of hands of a lot of engineers, which I actually think is a positive thing, including, which I'll get to, and I guess I should jump to it now to give away something that I was working on before the guy sent me these plans. Now I've got to redo a video. Michael, this guy, company spokesman Michael, well, I can't say his name, wouldn't say exactly what the crew was doing when the bridge collapsed, but he confirmed the workers were providing installation support for our products, was providing installation support, not, this is a different quote than I found earlier where they said they were post-tensioning, I believe it was. It's been out there. Documents from FIU and consultant Bolton Perez and Associates, obtained by the Miami Herald. So it appears that they had some other engineers on top of this. Show that Structural Technology LLC, VSL, was paid $439,000 for post-tensioning work. Now, we don't know the details of this. This could be the entire post-tensioning of the entire bridge. This contract could have existed beforehand, not as a result of a crack showing up after the fact. But what I do find amazing is that I showed in my previous video, if you find it, where while the bridge is still supported with the dolly, that the workers saying that before the dolly is removed, they're going to detension some post-tension members. Video I posted April 9th talking about the detensioning rods. It was supposed to have been done already, and that's part of the plans. We're supposed to be detentioned, but not removed.
The bridge now has been in place in its final position, so we're going to be getting ready to dismantle and remove the SPMTs from underneath the bridge back into the staging area. Right after that, we will continue with the demobilization of all the rope leads and detensioning of the 2 bars on top of the bridge. And right after that, we will be reopening 8th Street to the...
Okay. So detensioning 2 bars on top of the bridge. That's part of the steps. And now, I can't find a video, maybe you guys can find it, or any data showing they detensioned at that point before they removed the well, I guess they loaded it. And I can't find it where they removed it beforehand. But he makes it clear before they open the roadway, they're going to detention. So obviously, this guy knew that that was an issue that should be addressed before the road was open. And I'll back it up again.
Note of 2 things. He says 2 bars, not cables. Also, he says he's going to do it before they open the roadway. So they clearly had safety in mind, and the bars were detentioned before the roadway.
So now remember that I didn't have the new plans when I made this video, so I was just working on what my experiences are.
The bridge now has been in place in its final position, so we're going to be getting ready to dismantle and remove the SPMTs from underneath the bridge back into the staging area. Right after that, we will continue with the demobilization of all the rope leads and detensioning of the 2 bars on top of the bridge. And right after that, we will be reopening 8th Street to the...
Okay, they will reopen the bridge after that. So it appears that reopen the roadway. So it appears that they knew the hazard, as I stated in this video also, and they just went. They ignored their own procedures. Unless you can show me a video where it comes forward, then I retract that statement. Unless you can show me them detentioning the 2 that he was referring to. He did say 2. So if they were detention 2 down there, or anywhere, then that's all bets are off. They technically can say those are the 2 we were talking about. But apparently these are the 2 that need to be detentioned as the drawings currently show. The 2017 stamp drawings. Yet I could not find a video showing them doing that while the dolly was in place. So you guys are so awesome. Maybe you can find that for me. I'll work it out. So this is Structural Technologies structural group. They specialize in bridge repair, etc. And I'm going to jump around and cut to the chase here. I tried to find that jack, the hydraulic jack that they use on their website. I could not find it. And awesomely, I share this stuff with you guys, and you might find it. Someone that's really into this might find it. So here's an article from PalmBeachPost.com. Right there. Officially, the National Transportation Board told the Post that the construction workers were tightening cables on the pedestrian bridge before it collapsed. The National Transportation Safety Board told the Post that the construction workers were tightening. My videos take a lot of research, and in this case, I have the new stamp plans. So I have to go over every single thing in my mind before I make a post. With that said, I'm making this post before I finish all my details. This is how you connect rebar. It's a rebar coupler. Dayton Superior is a great company. I deal with them. It's how you join two pieces of rebar, not welding. This is how you keep it into the same stress as if it was not, if it was a solid piece. So they're using, this Pate is using some awesome stuff. This makes it idiot-proof when you do this. Now, you can torque this to a certain torque per the manufacturer's requirements. Let me say that, installation requirements. And you now made it so you can almost get any worker to do this, but you still need somebody to verify the torques. I'm not saying that caused a failure. I'm just saying that this is how Pate did an awesome job on that. So, you know, we're throwing everybody on the bus. And as I said, I've always said, I am the type of person that will go with the data. So this data now is getting pretty strong in the form of this bridge. I'm not a fan of their step processes of not having all this post-tensioning in there or not resolving that temporarily. And I have not read all the plans. Maybe they did have some temporarily post-tension going on and then removing. I don't want to keep this video long, but I want... Okay, I've highlighted here B39 under Section 8. Secondary pour shall take place 180 days after casting of main span, which is awesome. They show that they have a pure delay. I mean, this is beautiful for concrete to mature. That resolves that maturity issue of pouring too soon, as everyone's always calling it green concrete. I don't get that. Concrete can get the PSIs they need within 7 days. And I think they addressed that, and I addressed that in my videos, but they addressed it in here somewhere, that it stated something like it'd get to the PSI within 7 days of 65, whatever it needed to start a preliminary post-tensioning. I believe the preliminary post-tensioning is ideally what it's for. You like to get your concrete under some post-tensioning typically soon. It shows that number 11 does have post-tensioning bars installed. As you see here, this is the detail to help you guys understand this. You see the G and G. This is this direction. This means it's this member. And this member, you would find GG over here. It's member number 11. So GG, you go here, and you see the cross dimensions, 1'9" by 2 foot. This appears to be center line of the post, and high and low within these performances. And you can see the details again here. These two will be in equilibrium. Once the deck was in place, as I read quickly in these drawings, these were going to be detension. Number 2, remember number 2, far left, if you recall. Oh, I have it here. Number 2 and number 11 were detensioned. Number 8, post-tension bars in members 2 and 11 will not be grouted and will be distressed after main span construction is complete. Do not remove bars. So it appears this is very critical, but it says after main span construction is complete, do not remove bars. So the main span construction, when is it complete? That's an interesting question. After when it's on the before it hits the dolly, after it hits the dolly, or do they mean after it's complete? Does this complete mean installed at the location? All right. This is a hinge effect in concrete. See main span truss system reinforcement. This is the things I referred to you guys as a way to have expansion, etc. Have movement abilities. Let me address the kick out of, as the question arises a lot. This has been kicked out the backside, starting the movement first in the collapse of the bridge. This post-tension bar creates compression. There's the one anchor plate on the bottom end. As you're pulling on the top end, creating compression inside this, tension inside this member, inside this, when I say member, I mean this post-tension bar. When you're creating tension inside that bar, you're creating compression on the member here. This is the concrete member. This is a force going in. This force is being controlled by this nut on this plate. The force is in this direction. It's not a force in that direction. So that will not create, post-tensioning would not create a force in that direction. If it were to break at this point, all the forces would still go forward. It would still go towards the upper deck, not down this direction. So for your knowledge, all these little approach angles, see how it's not straight? All of this counts as positive or minus for the post-tensioning you're doing. Let's look at the transverse post-tensioning. This is transverse. These are longitudinal, the longer direction of the bridge, and anything going across them would be transverse. As you can see here, there's the transverse. I've already spoken to this in other videos. These are now the stamp plans. As you can see here, they were called for. So to change this to rebar, there is another set of plans that would allow detail to be changed. Another detailed plan showing this would change to rebar. Okay, as I always talk to you guys about reinforcement and conflict, here it is on their plans with the PE addressing that. I said that in one of my other videos, the conflict of materials. I think I did a whole video on about the one bar being in line with the post-tension member. Well, they're making it clear here that tendon, local zone reinforcement not shown in section AA. For clarity, local zone reinforcement shall be designed by the post-tensioning supplier in a manner that avoids conflict with reinforcement near the anchor face. So this is very critical here, that as you can see here, they did pass off their post-tensioning details to this post-tensioning supplier, which I think would be VSL. We just spoke to them. I just spoke about that a few moments ago. VSL, in other words, VSL, post-tensioning companies always have the issue here. Let me give you an example. When you see these buildings built, these skyscrapers, the glass guy puts the glass in, the glazing it's called. But then there's a glazing contractor that comes along and he does the caulking. He's an expert caulker, and they actually insure their work. And it might be, you might spend for the insurance on it, $50,000, $100,000 for a building just to have him bond his caulking or insure his work. Because as we all know, water can kill anything, and that is what you spend the extra money for. You just don't go caulk it yourself. Specifically, let's talk about Deviation system. Deviation system is a stucco system that a lot of contractors can install. But when it comes down to the caulking, a lot of them don't hire a professional caulker that would guarantee that, and that would stop the water penetration that causes that system to fail in most issues. That's what it was back in the 80s. So in a compliment to the bridge builder, they've hired outside professional post-tension contractors. They're not trying to double dip, which is great. Again, we have the post-tensioning transverse members going across the longitudinal members. This was not present in this construction. It's present in this detail. It's awesomely present. Specifically, I'm looking for this detail down the middle here. That's where the load transferred from the deck down the truss system. Truss members number 1 and 2. This is what it looks like at the bottom base of the bridge, basically. Not basically, this is what it looks like. This shows how they wanted the detail to be done. Coming back to number 11 and 12, this is the detail here. And again, we see the post-tension rod. So this would be the reinforcement cage, if you will, of concrete around that detail. And then we need 10 and 11 would be a nice detail. Here's 9 and 10 where they meet. And 9 and 10 does have some. So 9 has no post tensioning at all. Awesome. And number 9 does. Remember, I've always said about the forces going outwards, and when you apply the load onto the radius canopy deck, and that there's nothing underneath for that radius, underneath the nodes, the blister bars. I keep saying nodes, that's referred more specifically to the blister bars as they refer to them as. Notice the post-tension post-tension cables. There are 4 of them here, and this is a half, so it's going to be the other half is going to be the same as this, mirroring it, if you will. These loads, see how they jog, and they go along parallel to every blister, and then it'll probably be the same jog on the other side back in. So when you load this, the forces are created pushing in this direction, countering the forces from this pushing out. This would counter that force coming at each other. So the force is coming this way. And if I could flip my arrow around, it would be coming this way with these post-tension members pushing this way, if you will. And then the forces of the canopy and the radius trying to go outwards, if you will, forcing that way. And this would be countering those forces as I see it. All right, so there were only 2 of them in play. That's a lot less countering, if you will, or 2 on each side, should I say, and they were different varying sizes. Right? You have the 4 members here and the 4 members here, the post-tension cables. As this pushes down, as you can see, it's a radius. It wants to push out. These forces in that configuration, the forces in the post-tension bars in that configuration I just showed here, will counteract the forces of, ideally, when you're post-tensioning this member, of it trying to flatten this deck out. This is a camber, if you will, to allow for the way they resolve the camber and keeping the deck more flat, I think. Remember, this bridge has some unique details that are resolved, supposedly, cutting edge. And I think maybe this is one of the cutting edge details that resolving it. Ideally, I think this bridge, the crack sent these people on a wrong system. They sent them off their program, and when it sent them off their program, this caused the evolution. So, and perhaps and I want to be careful here, VSL was hired to do this post-tensioning to resolve that. This is the smaller span, and you have the 2 members here and the one on the outside. Boy, this begs to differ. That begs me to think that did they get these wrong, and I just would hate this. Think it was so simple as that they got their cabling wrong per the 2 bridges. They had too many people for that to happen. I have to think that that's just a bad file in my own brain. That can't be as simple as that. So we go back to the 4 members, the long bridge 175, and they were specific here, showing the 2 details. Going on to member number 11 now. Member number 11 was to have post-tensioning done, and all of the post-tensioning on this bridge was designed to be upstation, meaning above, on the top of the canopy. Here's your elongation, and this is awesome detail right there, 1.39 inches. And also, coming back to this is my last point to wrap this video up, and I'll do longer videos when I make more time, or you guys send me in the direction. In my previous videos, I was stating that the 2 bridges together possibly was going to have a post-tension, 2 more additional post-tension members going across from one bridge to the other, tying them the 2 together. And I also noted that I didn't like that idea. I just found it created some type of camber or some issue between the 2 bridges. Okay, so this bridge, the detail we see, this is as built, I would say, pretty much there. This is the stressing end. This is the non-stressing end. So going back to, again, you see the legend, stressed end, non-stressing end. That means the anchor end. Going back to my nodes, I see 2 stressing ends. And let's follow those over. 1 and 2, side by side. and then this one appears to, this one might go all the way through, and this one, so there's my correction, might go all the way through to the next deck. And that would put us back at those two again, 1, 2, the two pockets. So, yeah, it appears that they're going to go through the, two of these were going to go through this canopy, through the next canopy, and secure both bridges together. This is WD Pate with the post-tension details. This is not structures post-tension detail. This is Denny Pate's details on post-tensioning. Okay, so for clarity, I did find they were going to go through 2 decks. If we look at the length, main span and back span canopy, they were going to do 2 members at 272 feet. And that was going to be C1 and C4. We're going to do the longitudinal post-tensioning of both decks. C1, C4. Inner and outer was going to go longitudinal through both decks. C1, C4, C4, and C1. Okay, thank you. Guys, you can ask me anything. I'll work on this thing, but I need to take a break and get to work.